Okay, good afternoon, everyone. We're going to take attendance very quickly, and then we're going to get started shortly. Okay, so a few things to discuss. We know our exam is coming up very short, so our exam one, we discussed the exam, and for the first exam, it is going to be online. So that is not going to be this Thursday, it's going to be the next Thursday, so February the 19th. Okay, so just keep in mind that there will be no lecture next Thursday, and that time will be dedicated for your exam. Okay, and it's going to cover everything that we have discussed from chapter 1 to 5. So 6 is not included. Okay. Um, and depending on how we progress today, we're going to cover chapter 4. Obviously, not all of it. Is there echo? Or it's good. Okay. We're going to cover chapter 4 today, and hoping that we can cover everything. Obviously, chapter 4 and 5 before the exam. Um, so we'll just see how things go. Okay. So assignment 1 is in the process of grading. That was due on Sunday. And assignment 2 will be released today. Okay. Your second assignment will be about encryption, email encryption, using kind of an encryption tool, kind of just like how we demonstrated in class, using public keys and using private keys, how we can encrypt a message, a plain text message, verify that it was encrypted, be able to decrypt it. Also, includes digital signatures and like meaning integrity and integrity of the data and digital signature that you have sent the message yourself. Okay, so that is what it's going to be primarily about, and then a few questions that you have to answer as typical. You had a question?
You said that there wouldn't be a lecture in the exam as we had last time. We then say that the exam would be open only during our class closed.
I'm thinking obviously there will be it's either going to be within the class time that we have, so like from 4:30 to like what, maybe 5:45, or it might be an all day thing. So it just really depends. That's going to get finalized very soon because I do have some students that can't attend during class time, right? Yes.
Will we get a list of exam objectives for exam one, or should we just study everything we can for the start?
I'm gonna post like a kind of like a page on the modules that is gonna list what you should expect, like what the type of questions, what do the exam cover in terms of chapters and stuff like that. Okay, so I think it's pretty straightforward. And we will discuss the homework in the next class as well for anyone that needs clarification, but it's going to be very straightforward. It's something that everyone has been exposed to. You just kind of implementing and doing something a little bit different in a way. Okay. So just follow the instructions and it's going to be very straightforward. Yeah.
Um, will there be like an option for like notes if you print them out or handwrite them or anything like that?
I'm thinking to make the exam open book, open notes. It's going to be online, open book, open notes. So you can use your notes, you can use slides. So yeah, in that style. Yeah.
Are we thinking on multiple choice or some text box rather than?
It could be a little bit of both. That has not been finalized. When I post the details, you're gonna know what you expect. Whether it's like a quiz style exam, if you have to do a little bit of hands-on, maybe some case scenarios, demonstrations, like where you have to answer something based on like a scenario that is provided or an image that is provided, something in that sense. Yeah.
Do you have any plan like the exams?
No, I don't think a review is going to be needed. All you need to for the students to be prepped for the exam, the first exam, is just to actually watch, make sure that you have attended the lectures, watch the lectures, the slides meeting as well, and read those slides, watch the recordings, and that should be it. You should be prepped. You should not expect something that is outside this of something that we have not covered in class or covered in the chapters slides. Okay, yeah.
Sorry.
Now you're good.
You know if we're gonna need like a lockdown browser?
So I'm thinking to keep it online. So online, meaning like open book, open notes, no lockdown browser for the first exam. Yeah. Any other questions? Okay. So and obviously where we at, we're in week 5, and this chapter is going to be dedicated to access control. So we're kind of working in process in terms of security. We're building up in terms of what topics we cover. And we have covered chapter 1, which is an introduction, and 2 was about encryption. We know all the cryptographic tools that we have to assist to make our system secure. We talked about authentication with passwords, and we did a kind of a good demo for password cracking. Next, we move to access control. So we have one way of authentication to authenticate the users that we have to enter our systems, but we want to have some access control over what they can do. Okay, so based on their given role, maybe based on their given credentials. So that is what this chapter is going to be dedicated for. Okay. Okay, so almost every chapter, it really starts with a definition that is kind of standardized to what really the chapter is about, or kind of like this kind of key phrase or terminology in terms of definition. And access control is basically mentioned in the RFC 4949, and it's going to be something that is, as stated, measure that implements and assures security services in a computer system, particularly those assure access control services. Okay, so basically, access control is going to define what we can access. It can define how the access is enforced in the system, architecture-wise, and it usually sits after authentication. So authentication proves identity. We want to have some access control that decides the permission for this kind of authentication user that has been authenticated and verified. Okay, and basically access control with looks something like this that we have. We have obviously security administrator, and this can be an operating system. And we're going to talk about the types of access control today, but this one specifically here, we have a security administrator. It could be an admin that is basically writing some sort of access control policy for obviously maybe all the given entities to use or to follow, and storing it in a database. And basically that database is similar to how we store our passwords. We have a user ID maybe for each credential, and we can give them permissions on what they can do. And we're going to do a little bit with Linux today. We're going to make a new user, create some files, modify those files, and see if one user can access it or not. So we're going to play with the permissions. So the user would come in, and we discussed in the last chapter, authentication comes in by using the user ID and credentials, and we talked about that chapter fully in detail. After they pass this specific phrase, you can say in this specific phase, they will face the access control function, which allows them to do certain things within the system that is set by the administrator. Okay, and this access control will allow them to access certain system resources, right? And then we also have auditing. Auditing is basically, I think if you're a SOC analyst or you're working in cybersecurity or IT, almost across what you do, you have some sort of auditing or some sort of system that oversees what's happening and keeps logs of everything. Okay, so that's what the auditing really does. So the access control policies, we have the first kind of, you can say, policy. We have the DAC, the access control, and this one is how access is decided for this specific policy. So these are just basically, we have access control as on the top, and then we have various access control policies. Okay, so the way that it's decided on here, it's based on the identity of the user. Okay, so the resources owner controls the permissions. This is kind of similarly to what you have on your OSs. You as the user, based on your identity, maybe you have 3-4 users on your OS, and maybe one user has a capability of the resources and controls the permissions, such that maybe you can work on a code file, a doc file, and modify the permissions of the file. So the owners are really who decide who can read, write, and execute in this policy. And this is kind of similar like to a file permission in Linux or Windows. Okay. We move to the mandatory access control. That is our second policy that we have. And this policy is enforced by the system, meaning that kind of similar to what we've seen in the example, there's an admin or an OS that has embedded kind of access control list, and those lists have to be implemented. Okay, so the users cannot change the permissions. This is similarly to what when you go to your UCF libraries, you access the system to be authenticated by your credentials, but it's enforced by the system. So we're using a mandatory access control policy. So users cannot change permissions at all. So here what we have is we have a system administrator, and we have some configurations. We have users that we have some clearance level for these obviously users that are being provided to those users by the admin, and we decide access based on classification. And I think when in the next couple of lectures we're going to do something like that. Is obviously when we talk about big enterprises, they're not going to go and modify those one by one. What they're gonna do is they're gonna make multiple groups, right? And classify users into a certain group and assign them a role. Okay, similarly to like we have network admins, help desk positions. So we make a role for those and just throw everyone in there. Okay. And then obviously the system administrator provides access to the data. Okay, and it has some confidentiality that goes with it. So access is only allowed if security clearance matches the security labels. So basically what has been under kind of what user group you have been, if you have the same clearance, then you will have access. So for example, a user cannot open a secret file without a secret clearance that we have. We have role-based access control, and this is all based on role. So you have an admin that assigns user. We have many users here. This could be any of you. And each user kind of have like roles to do. And there's permissions that are set with these kind of specific roles. So based on the assigned role and permissions are linked to those roles. Okay, so maybe we have a role for just kind of like filling out information. And we can create a role for that, and we can create permissions for that role. So like you can only write information, not delete or modify, and you get the idea to an extent. So changing a user role automatically changes their access, obviously. So when you change the role of a user, it's going to change their access and the permissions under that access. So for example, I, as an instructor, can post grades. Students can only view them because that is my role. The role of a TA obviously would be a different role from you as a student. They can do a little bit more. Obviously, they can grade. Okay, and maybe I can oversee the TA. So that is really how it works with access control. And then we have attribute-based access control. And this is kind of based on certain attributes. It could be environmental attributes. It could be physical attributes that are set that would grant access to the system. So attributes describe users, resources, and environment. So maybe we can have here resource attributes like creation date, resource owner, user attributes like their name, role, or environmental attributes like the time or the location where you're accessing the system. So those are all can be used for attribute-based access control. So the decision is going to be obviously changed based on context. And only we allow from maybe, for example, allow access from campus during business hours, right? Maybe like 7 a.m. to 7 p.m., something like that. So that is an attribute-based access control that we have. So really, access control can be viewed kind of as subjects, objects, and access rights, right? The subject is going to be an entity, right, that is capable of accessing objects. Objects are going to be the resources that we have. So you as kind of a subject, this could be users, okay? And we can have like 3 classes. There could be an owner, a group, or a world, okay? So those are kind of like the objects, subjects we have. The object is a resource to which access is controlled. And usually the subject would try to access the object. So it is an entity used to contain and receive information that we have. And the access right describes which way we should allow access to that specific object by enforcing the policies that we had discussed in the last couple of slides. And obviously that could include like reading the file only, writing, executing, deleting, creating, search. Have you ever guys got files where you couldn't modify them? Like you can just read them, right? You cannot modify the files. So that is kind of like an access right that is set based on the file. So we have with the DAC access control, we know that the access is controlled by the resource owner, right? So the owners can grant or revoke access to other users. When you share a file with someone else, you can kind of modify that if you want. And the way we do that, it's going to complement, it's implemented usually in an access control matrix. We want to know kind of how are these policies kind of being enforced across users, role, and what they can do. And we use kind of an access control matrix. The rows are going to represent subjects and the columns are going to represent objects like file or resources. We have an example in the next slide. So each matrix is going to specify the allowed action, and they became unique with the way we write those. They could use kind of like a matrix. There's other systems. We can make a software app for that, and that just has been tweaked. So we're going to cover it from like you can say the vanilla matrix that we have and build our way up. So this is kind of an access control matrix. We have multiple users here. Those are the subjects, as we mentioned, user A, B, and C. And we have the objects, which are resources like file 1, 2, and 3, and 4. So the user, for example, user A, in correlation to file 1, they can only own, read, and write. So you get the idea. User A doesn't have access to file 2 or 4. User B with file 1, they can only read the file. So that is just an access matrix that we have. So the rows that we have are the users, and owners control access to their files. And the columns is the files that we have, which is the objects, the resources, as we mentioned, and the cell contents are the permissions, what they can do. Okay. So we have access control list. Have anyone heard of access control list before? Yes, where exactly? Okay, Linux servers. Anyone else? So access control list is not only enforced within access control in terms of securities, right? Obviously, it is in OSs like Linux. It can also be found in middle boxes, like when we're talking about networks specifically, right? We can have an access control list on the devices, like a router, a switch, a firewall, an IDS system that we have, Trojan detection system. So those access control lists are basically like permissions that are stored with each file. And each file keeps a list of users allowed to access it. So here we have this diagram, right? And each row is going to represent a file. This is kind of like the other way we can write the matrix. Here we're writing it based on users. We can do it the opposite here based on the file. Okay. So each row is going to represent a file, like file 1, 2, 3, and 4. And each blue box lists a user like A, B, and C. And then those are the letters that we have. And the R and W indicate if they can read and write, right? So that is another way that we can write these kind of permissions. So own means that the user owns the file and can change the permissions, like what we have here. Okay, so user C owns file 4. So you get the idea. So the really access control lists are going to answer the question, who can access this file? We have a capability list, and these are permissions that are stored within each user. And each user is going to keep a list of files that are allowed to access. Okay, so we have the diagram here, and we have basically rows, and the rows now are users, like user A, B, and C. And then each blue box lists what the user can access as we have. And there's obviously file names here at the top that we have. And we do have like the exact permissions, what they can do with that file. And owns basically is still the same, that the user owns that file and can delegate access. Delegate access may be like assigning the file to someone else or sharing that file with someone else. So also, what can this user access? This is basically for capability list. Any questions so far? Anything clear? Okay. Authorization table, we can have something like this. This is just basically get a list. This is just basically a different representation of what we just discussed in the last couple of slides. We have subjects, basically users, user A, B, C. And so there, the way we just store kind of like the access control policies with what they can access and the permissions they can get, it just has been changed and uniquely ran different times. Okay, so we have the subjects here, what they can do and what files they can access. Okay, so this is just a flat listing of who can do what to which file. We have extended control matrix. So with extended control matrix, the objects kind of increase. Right, we no longer just have kind of reading the file or writing a file. We just add more kind of objects. Okay, so The subjects remain the same. Those are always going to be user, like S1, S2, or S3, and or processes. Processes in the essence that it's a process, basically a task to be done, or an execution, something that has to be done on the OS, for example. The objects here can include files, processes, and maybe even devices. Okay, and we have some permissions that go beyond read and write, like we said, execute, control, wake up. So there's the correlation kind of expands. The matrix expands because we have these different, or you can say diverse types of permissions that are being added. So some permissions can be delegated. So those are the marked with a copy flag star here. Those can be like sent over. So all of these are being sent over to other users, for example. So that can happen as well. So the access control applies to all system resources, not just having resources like files and having access control for those, but we can also take other system resources like various permissions and also assign access controls for them as well. Okay. Okay, so subjects, for example, the users that we have don't really directly access the objects directly. So even though the request goes to the operating system, the system will check the permission, right? And this is the way that happens, is that when you're a user and you're trying to access certain information, you're going through an access control mechanism, which is the second kind of column that we have here. And basically, this is just a way to verify your identity so we can grant you the access. Okay. So here, for example, you can say user S wants to read kind of F. It goes through the access control mechanisms. We can have them kind of classified into types of mechanisms, like for example, file system. And the object of the user is to be, it wants to get access to files. So here we're talking about, we move our kind of, you can say from a hierarchical, from files to mechanisms within the resources that we can do. So if we want to access files or read the files, it goes through a mechanism and that would allow us. Okay. So what the system will do, the system will obviously get requests from users, whether it's write, read, wake up, grant, delete. For example, this year, user S wants to delete B from this specific user, and that is being implemented here. Okay, so it consults obviously first the access control mechanism, and then enforces the decision using the hardware or software. So it could be hardware or software thing. Maybe we have a policy to wake up a certain device at a certain time. So those can be made. Okay. So access control is enforced by the system, not by the users or the applications. So the system grants the permission. That's the kind of the second policy that we have discussed. We have access control here, system commands. You don't really have to kind of remember these, but these are just commands that defines the allowed operations on the access matrix, like transfer, grant, delete, read, create object, destroy, and you get the idea. So this is just kind of like, these are basically controls to how permissions are granted or transferred. It's kind of like when we do in Linux, we have certain commands that achieve certain things. This is similarly to access control stuff that we have. And basically it restricts who can modify rules. So typically only the owners or subjects with the control rights can modify these files for us. Okay, or these kind of like access control lists. So the idea is that the access control rules themselves are protected by the system. So we have protection domain, and basically protection domain is going to just define a set of objects and the access rights to those objects. So it represents what a process is allowed to do with the system. Okay, and in the matrix that we discussed, we said each row corresponds to a protection domain. This is just a fancy way we can call it. We have a protection domain. Basically, each row can only access certain things. They can not modify other things in the given system. Okay, and that given user can create process with the restricted privileges. So that process can run with a subset of user rights. Okay, so that is also possible. So the association between a process and a domain can be like either static, so it's fixed for a life, you can say lifetime of the process, or it can change during execution. We modify the basically the association between them. So protection domains separate user mode and kernel mode. That is possible. We have a user mode that is limited to certain access. And this is similarly to what we can do in Linux. If you just have a plain user and you're not using the sudo commands, you have limited access to certain things. You cannot really do stuff. We're going to examine this today. So that is restricted. And the kernel mode, when you take root access or you enable sudo, you get access to memory and instructions. Okay. We moved to a little bit about Unix, or maybe you can say Unix, Linux, access control modes. And I think from here, yeah, this is what we moved to a little bit of Linux. So I'm gonna switch my the Zoom really quick to here. Okay. So we're going to switch to a little bit of Linux. This is good for you so that you are getting a little bit hands-on with a different OS, Linux itself, for the ones that have not messed with Linux a lot. Well, you're going to learn some commands, and it ties back to what we have been discussing so far. It just kind of like helps you kind of visualize what we have been discussing and what we can do with access control. Okay, I'm going to switch this to a laptop. And, okay. Okay, so when we move, now we're talking specifically about Linux. So every file is managed by using indnodes, right? And those indnodes store kind of metadata, not just a file name. And we're going to see those right now. So meaning that it includes the owner, it includes the permission, includes the size and timestamps. So multiple file names can point out to the same indnode. That is possible, and permissions are enforced using the information that is stored inside the indnode. So the indnode is used to kind of like say, hey, what can Ali as a user do in the given OS or based on the specific file? Okay. So to view the indnode number, we do ls minus I, the file name, based on the file name that we have. Okay. Or we can view the indnode and its permission, and we do stat file name. So let's switch to a little bit to Kali here. I'm going to open a new command.
So to see where you're at exactly, you can do pwd, and that just lets you know where you are exactly in the directory right now. You can do ls, and you would see kind of, I'm going to clear this, ls, the current files that are there. For example, I have a file here which we use kind of for password cracking, the hash.txt, right? And we want to know some information about that file. We said so we can do ls minus I, and then we can do hash. So that is that number right there. That's the inode number that we have. And we said that is kind of like every kind of every file is managed by an inode. You can say that is just like a unique number that stores multiple things. To view those multiple things inside the inode for each file, is we do stat, and then we do hash.txt. So we can see certain things here. And if we go back to the slide. So the first thing that we have is it not only shows the inode number, but it shows kind of extra details. So it shows kind of like detailed of the metadata, the permission field. So here we have obviously the file, the size of the file. We have the inode number, which is the same one that we have here. We also have all the metadata. So one of them is the permissions, and here this is access. Okay. And these are basically every time you see a dash, these are basically different permission fields. So for example, if we have RW, and we're going to cover what like each mini kind of, we can say, permission field indicates. Usually the first one is usually who's the owner. So RW is usually going to be the owner. The owner can read and write. So if your name is listed under the owner permission field, you can write and read the file. The group is usually the second one, and that is read and write as well. So if you're within a group, and I think in the next couple of lectures, we're gonna make groups. So we're gonna make like a group for maybe finance and put some users in it and assign a role to that group. Okay. And the others is usually the third field, and that is for R. They can only read only. We don't want them to modify the file. Okay. So that is the ID. And it has obviously the last time it was accessed, modified, changed, and when the file was created, and that stuff. Okay, so all those information are stored inside the node. So the OS kind of stores this information for the files that we have. Okay. So we're going to create a directory here in Linux. So you're going to know how to make a directory. And a directory is basically just going to be a file. A folder. So we're going to make a folder inside, just as like this, similar to right click new folder. So this is the same. And we're going to inspect a directory and a little bit too, and just kind of see what it contains. So to make a directory, we're going to use mkdir, and you can put anything here for the directory. You can see I have already created one for the CIS. You can do anything here, maybe test. And then you can see when you click ls that you have test here is as a directory. We can change into that directory by using cd. And if you type the first couple letters, it should show you your directory, and then you can click enter. So now we're inside the directory, right? So pwd is going to display that path for us. So we're at home, I'm the user Kali, and I'm in the directory now, which is we have made test. Okay. And we know that ls show us the content inside that folder, and we currently have nothing now. It's empty. And ls minus l should show us kind of like the metadata summary, and we have nothing. There's no files that are stored just yet. Okay, so for you to go back to Kali and leave your directory, you would just do cd and you would exit out. So you know we're back in Kali. Okay. Yeah.
All the inodes, are those kind of like pointers of objects?
Yeah, so basically it's kind of like we have a subject. You can say that it's trying to access the object, which is an end node. And the end node is basically gonna have like a third kind of, you can say, row that contains all information about who can access the file. You know how we had in the figure here? The way we can store the information is maybe based on user or maybe based on file. Okay. So this is what we have did access control list kind of in a way. So we access the file and we can find information about it. Okay. We can also do it by user as well. So this is basically, yeah, that's correct. So we made the directory. So let's view some information about the directory. So, and we're going to use this command right here to display permissions of the directory itself. We want to find out who's the owner and what the owner can do with that directory. This is kind of similar to how we had it with the file. So if we do ls minus ld, and we're going to do test. So you can see that obviously I think time that was created and who's the owner of the file, which is Kali. And basically here, the permissions that are allowed. So owner and group and others. And they're basically in here. So the owner can read and write. They have full access. If you're a group, you can read and write as well. But if you're other, you can only read. If we do the same thing, stat test, and we can show the same thing. Okay, so it's basically showing off the directory that we have. So you get the idea. Any given kind of file or directory will have kind of the same thing. You can see that the endnode has changed for this. Obviously, the endnode is unique, and it's not the same per file or per directory. Okay, so let's create a file. So we're going to create a file, obviously, and we're going to put some text in that file. And we're going to display the ownership or permissions of the file. And then we're going to try to kind of like alter the file in a little bit of a way. Okay. So to create a file I'm going to clear, to create a file that we have, what we can do is we use touch. So you use touch, and then you input the file name that you want to create. And that could be anything like, maybe for example, we do demo.txt. And if we do ls, we can see that demo has been made. To add some text into that file, we can do echo. There's like visual text editors that you can use, but here we're doing it on command line. You can open file with text editors and write stuff in the file. So we're gonna do echo, and we're gonna write something. Use the kind of these to initialize what we want to write. So we can say CIS permissions demo, and then after we finish, this kind of like greater sign kind of stores that information in the file that we have that we just made, which is demo.txt. Okay. So that is what we have. So we want to know for us to find out what the owner is and kind of the permissions about the file. We do ls obviously minus l demo.txt. Okay, so that is what we have. Obviously the owner is Kali, and this is the permissions that we do have. If we do cat demo, and this allows you to see the file. CIC permission demo. We can access it here. Okay, so let us move forward with what we have. And okay, so for example, if we do a new user, right? And the new user is going to be the command for a new user is going to be user add Alice, for example. So we're going to do user add, and I think to verify if a user has been created, it will let you know. But if you can do ID Alice, for example, or ID the name that you have in mind. If there's no such user, then that means there's no user that has been created. So user add, for example, Ali, and you see there's permission denied to create a user. So this is kind of like we're talking about system privileges. So those are permissions. For us to do user add, we have to do sudo user add Ali. And then we're gonna enter the password for Kali that we have set up. And we're gonna do pass. We have not created a password yet for Ali, so we need to create a password. So we do sudo pass wdo Ali. So sudo pass w Ali, and I'm gonna create a user. Sorry, a password for Ali. So it's gonna be something simple. Okay, password has been updated successfully. So, for example, if we access the user Ali, we want to leave Kali and we want to access Ali to see if we can access the file we just made. Okay. So the way to do that is you can do, I think it's su. Su Ali. Enter the password. And when you see that $sign, that means you're actually in the given user. Okay. Otherwise, it would not let you to enter. Okay. You have no really as a user, you have nothing to be, you cannot view directories, you cannot change directories as well because that user has not been assigned permissions. So if we do cat in the file that we just made, which is demo.txt, permission is going to be denied because Ali is not the owner of the file, right? So you get the idea with kind of like permissions and privileges that can be added to the user to do certain things. Okay. Mhm. To change kind of like restrict access to owner only, we can do that using chmod 600 demo.txt. So that will fail if we want to modify the file. So if we want to change the owner, basically. So let us try that very quick. So we're gonna to exit out of your user to go back to Kali, you will just type in exit, or you can do control I think D. That gets you back to your home screen. So we want to kind of like attempt to restrict access to the owner only. And that could be done like this. So if we do chmod 600, and this will fail because we are not using kind of sudo. So if we do the ls minus l demo txt, you can see that here we changed the file just to RW. Okay, so just the owner only can access that file. And we have verified it with logging into another user. Okay, so restricting access to an owner file only. We did something like this when we created a file and the access can be only accessed to someone else. This creating a new user, we're going to create a new user very quickly for this last demonstration. So we're going to do user add maybe Alice. And we have to always remember to use sudo user add Alice, then pass w sudo pass w to enter a password. Alice, password for Alice, and we have created another user. Okay, that was good. We're gonna make a new file. So touch secrets.txt. Okay, that was good. We made a new file. And we're gonna do that same command, which is the sudo chmod, basically to kind of like only allow access to that file by a certain user. So to do that very quick, we're going to add some text to the file that we have very quickly. So we're going to do echo, like we said, and we say test here, stored it in that file that we have, which is secret.txt. Do that secret.txt. We can see the file that we have, and let's change kind of set permission to owner read slash write only. So we're gonna do sudo, and then we're gonna do switch mod 600, and that is the command for that secrets.txt. Okay, we have done that. Let's verify the permissions have been actually set. Yes, they have been set. So now what we do is try to see if, and we have added a user for Alice very quickly here. We have done that. And we want to change the file ownership to Alice. So because the file ownership now is only to by Cali. So we want to change the file ownership from one user to another user that we have. Okay. So we will do here, go back to Cali, we will do sudo, and we will do this specific command, chown Alice, assign Alice ownership of the file that we have. Okay, and let us see if the ownership has changed very quick. You can see that it has changed to Alice only now. And if we want to open the file here specifically by Cali, we should not be able to open the file because we are not the owner. Because the ownership has been assigned to Alice. So we can now open the file specifically, permission is denied. Okay, so the current user is Cali, have not accessed the file, so they cannot really access. If we switch to Alice, okay, and if we access the file, right, if we want to access the file still, cats, and we should have access to the file, secrets.txt, or no, cats. Permission is still denied, although we still have ownership of the file. And really the reason for that is that file permissions are only allowed to kind of like Cali, right? So we also have to modify that. So the file is stored in home/Cali. And when we accessed Alice, Alice doesn't really have access to that directory, right? Such that she is still the owner of that file, but she's still getting, what's it called? She's still getting denied access, okay? So if we do pwd and we're in home/Cali, so we're where the file is, but you can still see, even if we still have ownership of the file, we cannot view it. Because even the directory kind of needs to be assigned to Alice. We can assign her access to the directory so that she can access the directory itself. So the permissions are not enough. The user has to kind of also have permission to traverse the directory or to kind of view the directory. Okay, so what we're going to do is we're going to exit from Alice here. We're going to go back to Cali. Then what we are going to do is we're going to see the directory that we have, ls. We want to see who's an ownership of the directory that we have, home/Cali. So we'll take a look at that very quickly. /home/Cali. So we know that the directory is only accessed by Cali. No one can enter this directory that we have. So we want to assign kind of access also to Alice to access that file or to access that directory specifically that we have. So how do we do that? We have this command here. So we want to grant execution permission to others. We're going to use chmod and here, and we're going to allow access to Alice. Okay, so let's do that really very quickly. So that is going to be here. Mod SS to home Cali. And then we're gonna go back to Alice and log into Alice and try to view the file that we have. So now Alice should have access to the directory itself, not just the file. The file she's the owner of the file, but we want to view the file now. So we'll do cat home, Cali. Oof. So I'm gonna do cat home, Cali, and then secrets TXT. Okay, so now she can obviously, so we had to do two things for Alice to achieve access to the file. Give her permission access to the directory and change the ownership of the file under her name. Okay, so with Unix, we talked about these. We have three groups. We have an owner, we have a group class, and we have an other class, right? And each one of those is basically going to have a permission that is written under it, like read and write, only read, or can't even see it. So that is the typical approach that we have, and we showed that here when we do ls here in one of these that we had, like RW, and this is kind of like the first group. Okay, and we can do that for users, we can do that for groups, we can do that even by system resources to certain directories. Okay, so that obviously it's 12 protection bits. So specify read and write, execute permissions for the owner of the file, and that is going to be 12 protection bits that is going to be added. Okay. So the owner ID, group ID, and protection bits are part of the files and node that we do have. Okay. So this is all we have for this lecture. So hopefully for access control, and we still have to continue access control, but for the first part, we discussed access control and what do we hope to achieve. We know the different policies that we have with access control and how to store the objects, subjects, and resources that we have, how to grant permissions, permission to a certain file, lock a certain file with the permission, grant access to system resources as well. So you do get the idea. We have basically just with access control as a whole chapter, we have users, and we're trying to get those users access to certain things that they can do, whether it's system resources, files, or just any typical resources in the OS. So that's what we want to achieve. Okay. So that will be it for this lecture. Does anyone have any questions? Okay, I will see you all on Thursday. Any questions on Zoom? Thank you, Christopher. Have a good night. Hey, where are your
It's all work.